need to connect to an existing FastMCP server using the older SSE protocol while keeping your client code forward compatible. We'll configure the SSETransport with the server, SSE endpoint URL and authentication headers, using the same client initialization pattern that works across all FastMCP transports. You'll see how this maintains consistency with modern transports like streamable HTTP transport, where only the transport implementation changes, not your client setup. From FastMCP client transports, import SSETransport. Transport equals SSETransport. URL equals https://API example com/SSE. Headers equals authorization. Bearer token. Client equals client. Transport. This demonstrates the transport abstraction pattern, where SSETransport implements a standardized client interface for servers and events while maintaining compatibility with FastMCP's modern transport system. The concept provides protocol-specific implementations behind a uniform contract, allowing you to swap transports without modifying client code. The distinctive aspect is how it preserves the same initialization pattern and configuration options across different communication protocols. The pattern works by enforcing consistent parameter contracts across transport types, where both SSETransport and streamable HTTP transport accept URL endpoints and headers for authentication. While newer transports prefer the dedicated auth parameter, headers remain universally supported for backward compatibility and special cases. This design enables progressive migration. You can develop with in-memory transports, test with SSE endpoints, and deploy with streamable HTTP transport, all using identical client initialization code. This approach matters because it eliminates transport-specific coupling in your application logic. You gain the flexibility to upgrade server infrastructure independently from client implementations, using the same connection code for legacy, SSE endpoints, or modern HTTP services. The trade-off involves managing transport-specific URL formats and authentication preferences during transitions, but the benefit is seamless interoperability between different protocol versions and deployment environments. Let's break it down line by line. From FastMCP client transports, import SSETransport. Imports SSETransport, FastMCP's legacy transport for servers and events, required when connecting to servers running with MCP run transport SSE. The URL parameter must point to the SSE endpoint specifically, unlike streamable HTTP transport, which uses the base MCP URL. While both transports accept headers for custom metadata, SSETransport requires it for authentication since it doesn't support the newer auth parameter. This maintains interface consistency, letting you swap transports while keeping identical client initialization code. Transport equals SSETransport. Initializes SSETransport for FastMCP deployments using the legacy server-sent events protocol via MCP run transport SSE. The URL parameter specifies the SSE endpoint, while headers handles authentication since SSETransport doesn't support the newer auth parameter. This maintains interface consistency with streamable HTTP transport, allowing the same client code to work with either transport by just swapping the implementation. URL equals https://API example com/SSE. Specifies the SSE endpoint URL for FastMCP's servers and events transport, required when connecting to legacy deployments using MCP run transport SSE. Unlike streamable HTTP transport, which uses the base MCP URL, SSETransport needs the explicit SSE endpoint path. The headers parameter handles authentication here since SSETransport predates the dedicated auth parameter. though both headers and auth work with modern transports. This maintains interface consistency, letting you swap transports while keeping identical client initialization code. Headers equals authorization. Bearer token sets the authorization header for SSETransport, which requires headers for authentication since it doesn't support the dedicated auth parameter. While both SSETransport and streamable HTTP transport accept headers, modern code should prefer the auth parameter with streamable HTTP transport for new deployments. This maintains transport contract consistency, letting you swap transports while keeping identical client initialization code. This closing parenthesis completes the SSETransport initialization, which implements FastMCP's legacy server-sent events protocol. The transport requires explicit headers for authentication since it doesn't support the modern auth parameter, though headers remain valid in streamable HTTP transport as well. The consistent client initialization pattern allows swapping transports by only changing this configuration, enabling gradual migration while maintaining the same application code. Client equals client, transport. This initializes a FastMCP client with SSETransport, maintaining compatibility with legacy servers using MCP run transport SSE. The transport requires headers for authentication since it doesn't support the modern auth parameter, though headers work with both legacy and modern transports like streamable HTTP transport. The consistent client initialization pattern enables seamless transport swapping. Just replace SSETransport with streamable HTTP transport and update the URL to the base MCP endpoint instead of the SSE-specific one. SSETransport pattern. The SSETransport maintains compatibility with existing FastMCP2 servers using MCP run transport SSE, requiring explicit SSE endpoint URLs and headers-based authentication. While both legacy and modern transports support headers, SSETransport mandates this approach since it predates the unified auth parameter available in streamable HTTP transport. The consistent client initialization pattern across transports enables seamless migration by simply swapping transport implementations.
The endpoint that never changes becomes the bridge between what was and what will be.